All right, so we're going to finish up as much as we can. I'm going to watch the timer for 10 minutes of section 13.2 here. So from the last example, this was our W. Oh, and I said I was going to look up why this works. I'll look it up and tell you guys in class next time. Anyway, so what you do, just like you have the magnitude of a vector when it's in 2 dimensions, you do the square root of the first 2 parts squared added together. So when it's in 3 dimensions, the magnitude of that vector is going to be the square root, and you just square each part and add it up. So 25 plus 1 plus 9. And so you get, what, the square root of 35? No. Oh, 9. What am I doing? 16. Sorry about that. I'll just put a 6 here. All right, so anyway, 42. All right, so let me see if I focus a little bit. Just a little bit better. Okay, so go ahead and maybe pause the video and try this right here. But and I'll go and do it. All right, so let's find the component form here, and it's important for the direction right here. So remember, we have to do B minus A. So AB is going to be component form -1 minus 4. So -1 minus 4 is -5. 5 minus -7, 12. And -3 minus -2, so -1. The magnitude of AB is going to be the square root, 25 plus 144 plus 1. So that's 169 plus 1, so square root of 170. And you can just leave it like that. Like I don't need you to reduce the radicals or anything like that, because we don't need to waste our time doing that. That's fine. And that pen was no good. All right, so parallel vectors. So parallel vectors, they just like parallel lines, they have the same direction. So they have the same direction, and basically, like if you're thinking about a vector, like let's say the vector 2, 5, something like that. So you go over 2, 1, 2, 3, 4, 5. So right here. So that has a certain angle to it, like a certain slope to it, right? And so if you're going to have a parallel vector to that, and this is in component form, so they all start at the origin, but if you're going to have a parallel vector to this, then what's going to have to happen is it's going to be longer or shorter. I guess it could be the same length, but it's going to have the same angle to it, like the same slope, right? So it's going to be a vector that's going the same way, but it's going to be a little bit longer, or maybe it goes back the other way or something. So maybe it goes, back like that. Like those are parallel vectors, right? So they have the same direction, and what we're going to see is that they are scalar multiples. They're scalar multiples of each other. So for example, if you have, vector 1 is 2, 5, then a parallel vector to that would be, let's say I multiply everything here by 2. So that could be 4, 10. So they're multiples of each other. They're called scalar multiples of each other. So you could say that, V1 is parallel to V2, a little parallel line symbol there. Okay? All right, so let's just look at some vector operations. This is really just some stuff from pre-calculus and maybe algebra 2, maybe you did this. So basic vector operations. So when you have vectors, I'm going to draw a little vector that covers 2 lines right here. So that's my length, and I don't know, I kind of drew it at a 45-degree angle. So if I want to do double that, so if I want it double, that means I need to cover 4 spaces, right? So if I'm going to call this one V, then double V, keep the same angle, and that would be 2V, right? So it's a basic operations. I increased the length by doubling it. Okay, so I was multiplying by a scalar, you would say. Maybe I want to do backwards, so negative. So I reverse the direction, so it would be negative V. So the negative reverses the direction. Maybe I want to do negative 1.5V. So not only should I be going this way, I do another half of what I already had, increase the length basically, increase the magnitude. Okay, so that's great and all, you see the picture and everything like that, but usually what you're going to do is people are going to give you vectors and you're going to do the operations. It's like a little algebra problem to solve. So you're going to do 2 and then put vector v, negative 2, 1, plus w, so 3, 2, right? And basically you just kind of like sum it up there. So you have negative 4 for your x value here, plus 3. Well, negative 4 plus 3 is negative 1. And then you got 2 times 1 is 2, 2 plus 2 is 4. Okay? All right, and so that is very preferable to do things that way because it's just faster. So basically it would take 2 of these vectors in that direction and add on 1 of these vectors in this direction, and the result would be here. And I'll show you that down here a little bit. Okay? So down here, w minus v. So take w, 3, 2, minus v, which is negative 2, 1, and just do the math. 3 minus negative 2 is 5, 2 minus 1 is 1. Okay? All right, so let's go ahead and I'm going to visually show you this first one here. All right, and we can skip the second one, but let's see. So if I want 2v, so 2v, that would have been negative 4 and 2. That would have been that whole thing right there. So I'm going to start here and go negative 4 and 2. So that was that first vector. Now when you do vector addition, when you stop one vector, when you're adding another, you add it on to the tail of this one. So then I have to do 3, 2 on the end of this. So from here, because it's like I went this direction and now I want to add 3, 2 to it. So from here I go right 3 and up 2. So there. So this was 2v, this was w, and so the resultant is what it's called. So look at that. So if I connect my start to my end, look, it's negative 1, 4, just like we said over here. Okay, and that's called the resultant. That's a u, sorry, the resultant, that little part right there. Okay, oh, look, I have it right there. Resultant, displacement vector, same thing. Okay, and so if we did that here, it'd be kind of similar. So no big deal, but just so you can kind of review that in your head. All right, I got 3 minutes left. So unit vectors. So unit vector is basically what it's saying. It is 1 unit long. So the way that you make something maintain the direction but lose its length and make it down to 1 is you take a vector that you have and you divide him by his own magnitude. Okay, and so this will be a vector. It will maintain the direction. Maintain. Ooh, is that how you spell maintain? I feel like there's no I right there. All right, sorry. Anyway, maintain the direction of the vector, but reduces or makes the length equal 1. All right, makes the magnitude 1. All right, and so that's nice because then your vector doesn't have like a strength to it, it just has direction in a way. All right, so if we want to find a unit vector for here, I need to know the magnitude of u. So the square root, I got 16 plus 1, I'm squaring these, plus 4. So what's that? 17 plus 4, so 21, square root of 21. So it's going to be ugly, but the unit vector for that, I'll put u over the magnitude of u. So I will just take 4, negative 1, and 2, and divide it by radical 21. So basically you could leave it like that, or you could do this. You could say 4 over radical 21, comma negative 1 over radical 21, comma 2 over radical 21. Okay? However you want to write it, doesn't matter. All right, so I don't know if you remember from geometry or wherever you learned this before, but another way to write a vector, if you have a vector like, actually forget that arrow right there, sorry. Let's say you had a vector like, what did we have earlier? We had negative 2, 1. So we had vector v was negative 2, 1. Another way to write vector v is to write negative 2i plus 1j. So that was like another notation because I and j are your standard unit vectors. So the vector I is 1, 0, 0. The vector j is 0, 1, 0, and k is 0, 0, 1. Okay, and so if I wanted to write this vector u up here from earlier, I could write it in component form like that, or I could write 4i minus 1j, and you don't have to put the 1, plus 2k. Okay, so another way to write a vector w here is w equals 3i plus 4j minus 6k. And so if I wanted to write something in standard form like that, if I have an initial point and a terminal point, I could say that vector w is, and I'm just going to finish, sorry, I'm almost done, so I'm just going to finish up and go to like 12 minutes. All right, so vector w here, initial point, terminal point. So I do -1 minus -2. So that would be 1, so 1i. 5 minus -8, so that's 13, so plus 13j, and then 2 minus 3, so -1k. And again, those ones don't have to be there. So sometimes it's easier to put it in component form first, and then like put it in that form right there. All right, so this lets you also basically combine like terms. So if I wanted to find this right here, I have 2 of these u's minus 3 of these v's. Oh, this is supposed to be v. -I plus 3j minus 2k. And basically I combine like terms. I have 8i minus 3 times -1, so basically plus 3i. So I have 11i. I have -4j, and that'll be a -9, so -13j. And then I have 2k, and I got 6k, so 8k. And then it's just like you're combining like terms, so that would be the answer to that. Okay, that's it. I'll see you in class. Do not do section 13.2. You just watch the video, you got that, and take the notes, and 13.1, finish 13.1. All right, bye-bye.